Now the ninth question, they are asking you that suppose if you have a convex lens and if you cover half of the convex lens with a black paper, then will this lens form a complete image of the object or not? And you have to verify your answer experimentally also. So पहला उनका question है whether a half covered convex lens can form a complete image or not. So our answer is yes, the image formed will be complete. आधा image नहीं मिलेगा, ठीक है, आपको complete image मिलेगा. So answer will be yes, a complete image will be formed. Okay. But what happens if you cover half of the lens? Then the intensity of the image will be less. What do you mean by intensity of the image? Brightness of the image will be less. Why the brightness of the image will be less? You can understand it in very simple terms. See, suppose if you are sitting inside a room where there are 4 windows present in the room. Suppose if you close 3 windows and keep only 1 window open, then the intensity of the light in the room will be less. And suppose if you open all the 4 windows, then the intensity or the brightness of the light inside the room will be more. So it is similar to that. So now see, here experimentally you have to support your answer. So just see the ray diagrams here. This lens, in first figure, this half portion of the lens is covered, okay? This lens is covered. Object is placed at infinite distance, so the parallel rays of light will be coming from the object, and as this half portion of the lens is covered, no rays will enter the lens from this portion. So I have not drawn any rays in this portion, okay? This much lens is covered. So the rays will enter only in this upper portion of the lens. And we know according to the rule, when the incident rays are parallel to the principal axis, then what happens? The refracted rays will pass through focus. And at the intersection point here, the image will be formed. It will be point sized. Okay. Now we'll see the next figure. In next figure, what we have done? We have covered the upper portion of the convex lens. So the incident rays will enter the convex lens only from below the principal axis. And again here also the incident rays are parallel to the principal axis, and so the refracted rays will pass through focus, and again the image will be formed at focus. So in both these cases what we can see is the image is formed at same point, focus. Okay, here we covered the lower part of the lens, here we covered the upper part of the lens. But still, that didn't make any difference in the position of the image. Image in both the cases is formed at focus only. Nature of the image, it will be real, right? Because here you can see the rays are actually meeting. Here also the rays are actually meeting. So the image will be real. And we know that the real images are inverted. So the image will be real. It will be inverted. Its size will be point size. Okay, it will be diminished. Only the difference is that the intensity of the image will be less. Here also intensity will be less. Here also intensity will be less. Okay. Why? Because from here no rays are entering. If you see the first figure, then from this portion no rays are entering. If you see the lower figure, then from this portion no rays are entering. So the number of the incident rays are decreasing, and therefore the brightness, or you can say intensity of the image, will also decrease.